Okay, we're going to look at section 3.3, solving equations with variables on both sides. So you've already solved two-step equations, and now we're going to solve equations with variables on both sides. So our goal is to get the variable on one side and get all your constants on the other. So when we're going to look how to do this, we're going to look for the smaller variable and we're going to subtract it, and that way we will always end up with a positive variable, or we're going to try to always end up with a positive variable right now. So on page 133, example 1 in your book, we're going to solve 7n minus 5 equals 10n plus 13. So looking at this, we're going to look at our smaller variable 7n, and we're going to choose that term to subtract when we're combining them. So we subtract 7n from both sides. So we're left with negative 5n equals 3n plus 13. So we got all our variables on one side by combining the like terms, and now we want all our constants on the other side. So we have negative 5 equals 3n plus 13. All our variables are on the one side. And in order to put all the constants on the other side, we're going to subtract 13 from both sides. So negative 5 minus 13 is negative 18 equals 3n. Now we can use our do and undo chart, and we find that negative 6 equals n. Our next step is going to be to check our solution. So we have 7n minus 5 equals 10n plus 13. We thought n equals negative 6. So we plug in negative 6 and solve, and we get negative 47 equals negative 47. Now let's look at example 2 in your book on page 132, and this example talks about the word problem on page 131, and they want to know how many students must go on the trip to limit the cost to $10 per student. So we have the Spanish Club is arranging a trip to a Mexican restaurant in a nearby city. Those who must go share the cost, $60 of using the school bus. The restaurant's buffet costs $5 per person. How many students must sign up for this trip in order to limit the cost to $10 per student? So we have the cost per student times the number of students equals the cost of the buffet, which was $5, times the number of students, plus the cost of the school bus. And we want it to just cost $10 per student. So we wrote our verbal equation, and now let's substitute. We have $10, $10 times the number of students, which is S, and $5 for the buffet times the number of students plus $60 for the bus. And again, we want all of our variables on one side and all of our constants on the other. So we're going to choose the smaller variable, which is 5s, to subtract from both sides, so we still end up with a positive s. So 10s equals 5s plus 60. Subtract 5 from both sides. So you're left with 5s equals 60, and we use our do and undo chart. We're multiplying s by 5. So now we divide both sides, and we have s equals 12. So the club needs 12 students to go on the trip in order to limit the cost to $10. And we are going to check our solution. $10s equals 5s plus 60 if s equals 12. So we have 10 times 12 equals 5 times 12 plus 60. 120 equals 60 plus 60, which is true. 120 does equal 60 plus 60. So when we substitute our variable into our equation, we have a true equation, which means that s does equal 12. Now we're going to look at example 3, which is an equation that has no solution. There are times in math when there's going to be no solution, but we have to prove that. So we're going to solve 5 times the quantity 2x plus 1 equals 10x. And we are going to use our distributive property. So we have 5 times 2x plus 5 times 1. We have to distribute the 5 within the parentheses. Equals 10x, and we simplify. 5 times 2x is 10x, plus 5 equals 10x. And this can't be true, right? 10x plus 5 cannot equal 10x. 10x cannot be equal to 5 more than itself. So the equation has no solution. So we can prove this by continuing to try and solve. 10x plus 5 equals 10x. Subtract 10x from both sides, and you're left with 5 equals 0. And we know that this is not true. So the equation has no solution. So now for example 4, we're going to solve an equation with all numbers as the solution. So we have 6x plus 2 equals 2 times the quantity 3x plus 1. Again, we're going to simplify by using our distributive property. So we have 2 times 3x plus 2 times 1. So we have 6x plus 2 equals 6x plus 2. And that's true. So for anything that I put into x, both sides are going to be the same for any value of x. So this equation has every number as a solution. We're going to do one more example. Example 5 is solving an equation to find a perimeter. So you guys know that perimeter means the distance around. So the perimeter of a square, you would add up all the sides, but you also know that a square has all equal sides. So if you have a square with x plus 4 as one side and 2x as the other side, we know that these two things must equal. So we're writing an equation and we're going to solve for x. So I set x plus 4 equal to 2x. So again, we're going to choose the smaller variable to subtract so that we end up with a positive. So I subtract an x from both sides and I'm left with 4 equals x. So now the question was to find the length of one of the sides of the square. And we're going to substitute x equals 4. And I can use either side because it's going to be the same thing. So x plus 4 equals 2x. If x equals 4, so you'll see x plus 4 equals 4 plus 4 equals 8, or 2x equals 2 times 4, which is 8. So one side length is 8 units. Now to find the perimeter, we can either add all 4 sides, we can either do 8 plus 8 plus 8 plus 8, or we can just multiply one length, 8, times 4 sides. So 8 times 4 is 32. So the perimeter of the square is 32 units. Now you guys need to try these problems and show all your work. It's really important. I keep stressing that, and unfortunately many of you missed points on your test because of it. So we have 13x plus 9 equals 11x plus 13. Negative 3k minus 25 equals 5k minus 1. 6 times the quantity 1 plus 5y equals 30y minus 2. And negative 14 plus 7m equals 7 times m minus 2. So please take notes on the video, ask me some questions, and I will see you guys tomorrow.